Hi everyone, welcome to Mathly. Today we are diving into logistic regression, one of the most important techniques in machine learning and data science. It's a powerful tool used for classification problems where the goal is to categorize data into different groups, like predicting whether an email is spam or not, whether a customer will make a purchase, or even diagnosing diseases based on symptoms. Unlike linear regression, which predicts continuous values, logistic regression helps us determine probabilities and make binary or multi-class classifications. It's widely used in fields like healthcare, finance, and marketing because of its simplicity and effectiveness. In this video, we'll break it all down: what logistic regression is, how it works, and how you can easily apply it using the Orange data mining software. By the end of this tutorial, you will have a clear understanding of how logistic regression can be used in real-world scenarios. Let's get started. Before we jump into the demonstration, let's first understand what logistic regression is and why it's important. Logistic regression is a statistical method used for classification problems, particularly binary classification, where the outcome falls into one of the two categories, like yes-no, pass-fail, or 0-1. Unlike linear regression, which predicts exact numerical values, logistic regression estimates probabilities and helps us decide which category an input belongs to. This is achieved using the sigmoid function, which converts predictions into probabilities between 0 and 1. For example, if we want to predict whether a student will pass or fail an exam based on study hours, logistic regression won't just give a score like 72 or 85. Instead, it might output a probability like 0.78 or 78%. If this is above 0.5, we classify it as a pass, otherwise it's a fail. This method is widely used in real-world applications like spam detection, medical diagnosis, and fraud detection. Now let's see how it actually works. Applying the sigmoid function. At the core of logistic regression is the sigmoid function, which converts any numerical value into a probability between 0 and 1. Instead of predicting continuous values like linear regression, this function helps determine the likelihood of an event happening. The formula is P equals 1 over 1 plus e to the power negative z, where z is a linear combination of input features such as study hours, traffic level, and other relevant factors. But what does this linear combination mean? Think of z as a weighted sum of all input features. Z equals w1x1 plus w2x2 all the way to wnxn plus b. Here, x1, x2 all the way to xn are the input features, for example, study hours, sleep time, etc. w1, w2 all the way to wn are coefficients or weights that determine the influence of each feature. B is the bias term, allowing the model to make better predictions when all inputs are 0. During training, the model learns the best values for these coefficients to minimize classification errors. Once Z is calculated, it is passed through the sigmoid function, which transforms it into a probability between 0 and 1. Decision boundary. Once we get a probability from the sigmoid function, we need a rule to classify the result. We set a threshold, usually 0.5. If the probability is greater than 0.5, we classify it as class 1. If the probability is less than 0.5, we classify it as class 0. This threshold can be adjusted depending on the problem. For example, in medical diagnosis, we may want a stricter threshold to minimize false positives. Training the model. To make accurate predictions, the model needs to learn from past data. It does this by adjusting weights or coefficients assigned to each feature. The model minimizes errors using an optimization technique called gradient descent, which gradually updates the weights until the predictions are as accurate as possible. Now that we have an understanding of how logistic regression works, let's move on to implementing it in Orange data mining. Now, let's move into Orange software. For this video, I have kept the setup simple and easy to follow. The dataset we will use is the Indicators of Heart Disease dataset from Kaggle. I have imported the heart disease prediction dataset from my local machine. After loading the dataset, I have used the data table widget to explore the data. Here you can see different health indicators for individuals, each representing various lifestyles and medical factors. The target variable we want to predict is heart disease, which is a binary classification, yes, indicated by 1, or no, indicated by 0. This dataset helps us understand the correlation between these factors and heart disease risk. For example, let's take a look at the first row of data. The BMI is 16.60, which is considered underweight. The person is a smoker. They do not consume alcohol. The physical health metric is 3.0, indicating the number of days in the past month when they experienced poor physical health. Their mental health metric is 30.0, suggesting that they reported nearly the entire month as mentally unhealthy days. The individual is a female. And there are many other metrics. The target column, heart disease, is marked as yes, meaning this person has been diagnosed with heart disease. This dataset contains thousands of similar records, helping us analyze how factors such as BMI, smoking, physical activity, mental health, and other metrics contribute to the risk of heart disease. Next, I have used the Data Sampler widget to split the dataset into training and testing data. The training set is used to train the model, while the test set is kept separate to evaluate the model's performance on unseen data. This ensures that the model does not memorize the training data but generalizes well to new cases. So here I've used 80% as training data and 20% as test data. With the features selected, I have added the Logistic Regression widget. This is a classification model that predicts whether a person has heart disease based on various health indicators. Logistic regression works by analyzing patterns in the data and estimating the probability that an individual falls into one of the two categories: having heart disease, yes, or not having heart disease, no. For example, if someone has poor health habits, an unhealthy lifestyle, and a high BMI, the model may predict a higher risk of heart disease. On the other hand, someone who exercises regularly, maintains a healthy BMI, and gets enough sleep is more likely to be classified as having a low risk. The model assigns probabilities to each outcome and makes a decision based on these probabilities. Logistic regression is a great choice for binary classification tasks like this because it provides clear, interpretable results while effectively capturing relationships between lifestyle choices and heart disease risk. To evaluate the model, I have used the Test and Score widget. This calculates important performance metrics. Accuracy, how often the model predicts correctly. Precision and recall, how well it detects actual cases of heart disease. F1 score, a balance between precision and recall. These metrics help us understand how reliable the model is in predicting heart disease. The Confusion Matrix widget provides a visual representation of how well the model classifies individuals as having heart disease or not. It compares the model's predictions with the actual values from the dataset, helping us assess its accuracy and identify any misclassifications. In this matrix, the y-axis represents the actual values and the x-axis represents the predicted values. 231,998 cases were correctly classified as no or healthy individuals. 2,308 cases were correctly classified as yes or people with heart disease. 1,924 cases were misclassified as having heart disease when they actually don't. 19,606 cases were misclassified as healthy when they actually have heart disease. This breakdown helps us understand the model's strengths and weaknesses, revealing how well it distinguishes between healthy individuals and those at risk of heart disease. And then I have added a new file widget called File Test, where I have included 10 rows with the same feature columns as the training data. This testing dataset will help us to test how well the model predicts on completely unseen data. The Predictions widget allows us to see how the trained model classifies new individuals based on their health indicators. It takes the input features and applies the trained logistic regression model to predict whether a person has heart disease. For example, let's consider the first prediction. The person is in the 60 to 64 age category. Their BMI is 22.5, which falls in the healthy range. They are not a smoker and do not consume alcohol. They have not experienced a stroke. They reported 2 days of poor physical health. Their mental health score is 15, indicating some mental distress. Their biological sex is female, and there are other metrics as well. Based on these factors, the model predicts that the individual does not have a heart disease. By analyzing such predictions for multiple individuals, we can understand how different health and lifestyle factors influence the model's decision making and assess its accuracy. Logistic regression is a simple yet powerful tool that is widely used across various industries. Let's take a look at some real-world applications where it plays a crucial role. Medical diagnosis. Doctors use logistic regression to predict whether a patient has a particular disease based on symptoms, test results, and medical history. For example, given a patient's blood pressure, cholesterol level, and age, the model can estimate the probability of heart disease. If the probability is high, further tests or treatments can be recommended. Email spam detection. Email providers use logistic regression to classify emails as spam or not spam based on features like subject line, sender, and content. If an email contains suspicious words or an unusual sender, the model assigns a high probability of spam, moving it to the spam folder. Customer retention and churn prediction. Businesses use logistic regression to identify customers who are likely to cancel a subscription or stop using a service. By analyzing customer behavior such as login frequency, past purchases, or customer support interactions, the model helps companies take proactive steps to retain users. Loan approvals and credit scoring. Banks and financial institutions use logistic regression to determine whether a person qualifies for a loan based on factors like credit score, income, and past loan history. If the model predicts a high probability of repayment, the loan is approved. Otherwise, the applicant may be asked for additional guarantees. As you can see, logistic regression is used in a variety of fields from healthcare to finance and marketing, making it one of the most valuable techniques in predictive modeling. And that's how you can use logistic regression in orange data mining. Today, we explored what logistic regression is, how it works behind the scenes, and how it can be applied to solve real-world problems. If you found this video helpful, don't forget to like, share, and subscribe to Mathemly for more data science tutorials. Comment below with what you would like to learn next. Thank you for watching, and see you next time.